8.1 is a pretty broad section looking at different types of sampling, some frequency distributions, graphs. So make sure that you read this section well. Look at number 1. Government of a large city needs to determine whether the city's residents will support the construction of a new jail. Describe the population. So the population, obviously, is the people that we're dealing with, which would be the city's residents. Kind of a no-brainer there, but you'll see the problems in your homework that deal with that are pretty similar. Number 2 says, the government of a large city needs to determine whether the city's residents will support the construction of a new jail. The government decides to conduct a survey of a sample of the city's residents. Which one of the following procedures would be most appropriate for obtaining a sample of the city's residents? So we want to make sure as we look at the option that there's nothing that's biased. We want to make sure that there's nothing that might be just out of convenience, and also look to make sure that it's not systematic. You'll see that that's one of the types of sampling that can be done. We want it to be completely random. So the first one says random sample, but it's of the employees and inmates of the jail. So it's not of the city's residents. So this would contain bias. 2, or part B says, survey every 5th person. Now when you see something like that jump out, that's very systematic. So that's not going to contain the bit of randomness that we would need for it to be a random survey. C says survey a random sample of persons within each geographic region. So that's probably looks promising there because it is random and they go to all different parts of the city, so there's not going to be a bias on maybe where the jail is. And you can confirm that by looking at D, survey the first 200 people. That's considered a convenience survey, so it's not random enough for what we would need, and we're looking at what the best procedure would be. 3A, a random sample of 30 college students is selected. Each student is asked how much of her it must be her or time he or she spent on homework during the previous week. Following times and hours are obtained. We want to construct a frequency distribution. Now you would see in your textbook to do that, the frequency distribution, you can have classes here or you can have just the individual hours. So since they haven't given us classes to start with, we're going to label this well as time spent on homework, and this would be the frequency of that. Number of students would be our frequency. So we're going to list 15 through, looks like the largest piece of data is 24, and as you go through, even if there are none, we want to stay, if we're going one by one, if our class width is just 1, we've got 15, 16, 17, 18, 19, and you're going to keep going without skipping until we get to number 24. And then as you go through and count the frequency that this occurs, 15 occurs 4 times. 16, and I've gone through obviously before this, occurs 5 times. 17 is 6. 18 is 5. 4. 20 is 2. 21 is also 2. 22 there is none. 23 doesn't occur at all. 24 is 2. And then just to make sure, because sometimes it's just easy to miss one, you might want to go through and kind of cross out as you document it. But add this up, and that should be the same total. It says a random sample of 30 college students, so that you know you haven't missed any. So that should always be the same. 3B is going to be a stem and leaf plot. So 3B says a random sample of 40 high school teachers is selected from all the high schools in the school district. The following list gives their ages. So I've got stem, and I've got the leaves, Okay, the stems here are going to be, since these are all in 2 digits, they'll be our tens digits. So you can see that the smallest number is in the 20s. Looks like 28, a couple of 28s, 25. So we're going to start with 2, and we're going to continue to go up by 10. So 20s, 30s, 40s, 50s, 60s seems to be the largest. And then this does not need to be in a numerical order. If I look at the number 63, I'm going to have 6, 3. And then I've got 48, so 4, 8. I've got, we're going to keep going through 42. And actually, just to save time a little bit, I'm going to go through and list kind of the completed stem leaf. So 8895, 870127645, 822145446. This keeps going out. You would want to line them up as best as possible, because what ends up happening, and with all of these graphs, at a glance you can tell it's a sideways histogram if you look at these kind of as the bars, but you can tell at a glance, oh wow, the most would be in the 40s, and you can tell that, you know, past that, the 30s and the 40s seems to be the most amount of high school teachers in the district that's the age that they are. So it's just a good way to see, you can see every bit of the data, but you can also, the way that it's listed, tell immediately that most teachers in this school district are in their 40s. Okay. Number 4, you won't be constructing circle graphs, but the main thing you want to make sure in a circle graph is that all of the percentages add up to be 100%, and also we just have a common sense that if something is going to be half of a circle, that should be represented by around 50%. Same thing for a fourth of a circle should be about 25%. So look and see if anything looks odd or strange. And you can see that in this problem, that 29%, they've actually on the graph represented that with something that looks more like half of the circle. So that's what would be misleading here, that 20% looks like 50% in the drawing. Statistics can be misled. Look at the one in number 4, cosmetic effects of homes with equal heights, and it looks like this one. It says the frontal additions, it kind of makes it impossible to tell if they depict the areas, because of, you know, a house, if you're just looking at the front of the house, it could be not very deep, or it could go back really, really far. So first of all, that doesn't really depict it well, and that would probably be the biggest thing. This could be, you know, one room thick, or it could go back and be a huge house that goes, you know, through like that.